Hello, welcome back to our studio practice again. Today, we are going to explore a path-based modeling workflow in creating another game model, a science fiction lantern. In this practice, you will need to think in a conceptual model of a silhouette, which commonly known as a positive or negative shape. Based on the silhouette of a lantern, we are going to trace its shape digitally, then converting it to a vector work path. Then we will bring the vector work path into a 3D environment and revolve it into a B-spline surface model. Later, we shall convert it into a polygonal game model. So let's get started with our Photoshop applications. Go to the File menu and open up the provided silhouette template named lanternpath.psd. In this tutorial walkthrough, I will be working slowly on the Mac platform. The demonstrated method here is certainly cross-platform, and you need not worry about the differences between the working interfaces. Okay, with the provided template, we are going to trace this guiding path as closely as possible. And to do this, we will need the use of Pen tool. Go to your toolbox, which on your left screen, and select the Pen tool. Before we begin, do ensure your pen tool is set to path only without a layer mask. Now, let's start on this top corner edge. Do click on it with your left mouse button and slowly moving your way down. To trace a straight vertical or horizontal line, just simply hold on to your Shift key. Don't worry about any mistake during this tracing process, and you need not to undo the actions. We can always adjust our path later when we are done. For instance, I have made a mistake over this spot. No worry, just carry on. Go to the spot and click on the misalign vector point. Then you could simply use the keyboard arrow key for nudging it back to the shape. Or you could use the mouse to move it as well. Once done, do take your time for inspecting on other vector points and fine-tuning their positions. When you are done, do switch your tool to pen selection mode. Then drag a selection fill for covering the entire vector path. As we are about to go into export our vector path. Now go to the File menu, look for the Export function and choose Path to Illustrator. This will write our vector path into the Adobe Illustrator data type. Do set it as a work path and save it to your own working folder. Good. Now, let's jump to our Autodesk Maya applications. Go to the File menu and choose Import, as we are going to bring our vector path into a Maya environment. Here, you shall see the vector path being inserted into our perspective viewport. Select the path and hold on to your Translate manipulator. By activating the Translate manipulator, you get to visually access its pivot point positions. Now, let's switch our viewport to front view. With the vector path still in selection, hold down your right mouse button and switch to the Control Vertex mode. Then, highlight all the vertices, turn on the Snap to Grid option, and move the whole vector path 4 units to its left as the demonstration here. You will notice that the vector path is not set on the ground zero if you zoom your view close enough. Let's correct this. Press and hold to the D key for activating your local pivot point. Then, hold the V key together for snapping the pivot point to the lowest vertex point. Good. With the snap to the grid option still on, just move the path downward for touching the ground zero. Once done, go back to our perspective viewport and switch our selection to object mode and make sure the vector path is still selected. Then, go to the shelf, look for the Surface tab. Click on the Revolve function. Here, you will see the vector path being revolved around the y-axis and connecting each other. Turn on the shading mode and the wireframe and hide the grid away. You shall see a spline surface model being created. A spline surface model would provide a very subtle smoothing angle for its surface. However, it is no good and can't be a game model as all GPUs pipeline with only efficient in rendering polygons. Now, let's go to the Modify menu, look for the Convert function, and click on the Knobs to Polygons option. Set it to quads and count with 180. Then click Apply. Here, back to the viewport, you would see a whole new polygon mesh being intersect in the middle of the surface model. Now, let's drag the polygon mesh out with the Move manipulator tool. Do have a good look at these two different surfaces. And by default, any converted model would tend to have higher degrees of polygon count. Now let's remove this NURBS surface model and its formation's vector path. Reselect the remaining polygon mesh and set its position X back to 0. Turn off the Snap to Grid options. With the model set back to origin, now we are going to optimize it into a game mesh. You would see there are numbers of close range vertices along its surfacing angle when check it with a close-up view. To optimize this model, the first thing to do is to get rid of these vertices. Let's zoom out and select all its vertex. Go to Polygon Shelf and click on the Merge Vertices functions. And you will see some vertices have merged but not some others. Double-click on these functions again to call up its setting. Let's increase its threshold to a higher value and then click Apply. You shall see those extra vertices being merged separately. At the moment, the mesh has quite high poly count. And before we optimize the mesh further, let's check its facing normal for all faces. Go to Shading and turn on the back face culling. Here, you will find that the mesh has flip normal. The cause to this is happened during the revolve operations earlier, as the revolving axes are in opposite value. Now, let's fix these flip normal faces back by simply activating the reverse normal functions. Okay, good. Now let's close this gap of the mesh. Select its edge and go to Edit Mesh, look for the Merge to Center functions. Once the gap is closed, we are going to remove these additional edge loops that don't contributing to the form of the mesh. Okay, we have done with our first level of optimizing task. Let's give our mesh a name through the channel box. Next, we are going to unwrap the mesh UV. First, let's split our viewport into two and embedding the UV editor into one of the viewports. Here, you would see the UV's coordinate doesn't match with our 3D mesh here, and we need to reproject it. For this mesh, you can choose to use the cylindrical projection method for unwrapping the mesh. However, this approach does not able to deliver a distortion-free UV layout. Let's switch to the top view as we are going to use an alternate way to unwrap the UV. As you can see, this mesh is a repetition of a same segment. All we need to do is just unwrap one of its parts and duplicate it back later. Let's delete the other parts and concentrating on one of the segments. Set the scale mode to none and click Apply and close the dialog box. Now let's concentrate on the UV editor only. For the remaining demonstrations, it will be about the sewing the UV edges for forming a cohesive layout. Do space out the faces a little bit before use the move and sew UV functions. And let's start with these edges. Okay, we have done with stitching all the UVs. Now let's scale it to fit into the normal zone, as later we are going to snapshot it. Here, I will create a whole new texture folder for housing all my texture maps. Once done snapshot the UVs, let's head back to the perspective view and switching back to Adobe Photoshop. In Photoshop, open the UV image and feel free to create a bar map for it. In the actual practice, feel free to experiment with all sorts of motifs for forming an interesting sci-fi pattern for your lantern mesh. Remember, a bump map should be black and white only. Do save your bar map into a whole new TIFF file without layering and alpha channels informations. When you are done saving, jump back to Maya and assign a new blend shader to your mesh. Press Ctrl T for calling the Assign Material menu. There are lots of construction history attached to this mesh. Let's clear it. In the Blend Shader tab, remember to give it a name before assigning a bump into it. Once you have done with bump map setting, turn on the texture shading with a high quality preset. Here, you get to see how your design is fitting with the mesh. You can always go back to adjust its bumping depth or even the design in Photoshop, and fine-tuning it is specular shading as you like. To put the mesh back to its original setting, all you need to do is to use the duplicate spatial options and duplicate it along the rotation Y. Do combine and merge all the vertices when you have reassembled the mesh back into a lantern form. And please make use of the Soften Edges functions for blending all the face-set looking surface. The Softening Edges function would certainly make a difference to our mesh quality. By using this method, the mesh would only use a small amount of pixel resolution for its UV space. You should share the remaining pixel resolutions with other meshes. And this is the outlook of this work-in-process sample mesh. Do try to add a color map for it. And here marks the end of this demonstration. I'm Chris Cheng, your digital tutor, and thank you. See you again.